Hi, I'm Matt, and in this video we are going to go over one of the important gas laws known as Gay-Lussac's law. Before we get into what Gay-Lussac's law is, we have to go over what temperature and what pressure are. So temperature is the average kinetic energy of all the particles in a sample. And for gas laws, it has to be measured in Kelvin. If it's measured in Celsius, we're going to have to convert to Kelvin. And then pressure is the force exerted on the walls of a container by the gas particles it contains. And it could be measured in many different units, such as atmospheres, pascals or kilopascals, millimeters of mercury, and torr. Although generally we're going to use atmospheres or kilopascals. Since we have to convert to Kelvin to use Gay-Lussac's law, let's do a quick practice question together where we convert Celsius to Kelvin. So to convert Celsius to Kelvin, we're going to use the formula that the Kelvin temperature is equal to the Celsius temperature plus 273. So let's try to convert 74 degrees Celsius to Kelvin. We're going to plug in that 74 for C and get that the Kelvin temperature is equal to 74 plus 273. Adding that together gives us that the Kelvin temperature is equal to 347. So 74 degrees Celsius is equivalent to 347 Kelvin, and if we were to do a problem with this, with Gay-Lussac's law, we would use the 347 Kelvin instead of the 74 degrees Celsius. Now, with that out of the way, we could start talking about Gay-Lussac's law, which says that the pressure of a gas is directly proportional to the temperature in Kelvin, assuming that the volume remains constant. This means that when temperature increases, pressure will increase as well, and when temperature decreases, pressure will decrease. They will always move in the same direction. Although more specifically, doubling the temperature will cause the pressure to double, and halving the temperature will cause the pressure to halve, assuming that those temperatures were in Kelvin. The last thing we should talk about before we get into the mathematical part of this is that since there is a direct relationship, a graph of temperature versus pressure will yield an upward sloping straight or linear line. Lastly, Gay-Lussac's law can be mathematically written as P1 over T1 equals P2 divided by T2, where P1 is the initial pressure, T1 is the initial temperature, P2 is the new pressure, and T2 is the new temperature. So his law states that the initial pressure divided by the initial temperature is equal to the new pressure over the new temperature. Now, let's try some examples with this. For our first example, we are told that a sample of gas initially has a pressure of 3 atmospheres at an unknown temperature. When the temperature is increased to 600 Kelvin, the pressure increases to 6 atmospheres. What was the initial temperature? So the first thing we're going to do is that we're going to write our givens. We're told that our initial pressure, or P1, is equal to 3 atmospheres. And then we don't know what T1 is. That's what we're solving for. We are also told that the temperature is increased to 600 Kelvin, so that's our T2 value. And then we're told that our new pressure is 6 atmospheres. Our next step is to write our formula, that P1 over T1 equals P2 over T2. And then we're going to plug in everything we have. So we have 3 atmospheres over our unknown T1 is equal to 6 atmospheres over 600 Kelvin. So now we could do the math on the right side, and we get that 0.01 equals 3 over T1. Now, we're going to have to cross-multiply to get T1 by itself. So we're going to put 0.01 over 1, and we're going to cross-multiply. 3 times 1 is 3, and that equals 0.01 times T1. To finish up, we have to divide by 0.01, and that will give us that T1, or our initial temperature, is equal to 300 Kelvin, and that is our final answer. For our second example, we are told that a sample of gas initially has a pressure of 10 atmospheres at a temperature of 227 degrees Celsius. When the temperature is decreased to 127 degrees Celsius, what is the new pressure? So we're going to start by writing our givens. We're told that our initial pressure is equal to 10 atmospheres. We are also told that our initial temperature is 227 degrees Celsius. But we have a problem, because to use our gas law equation, all of our temperatures have to be in Kelvin. So we're going to use the formula Kelvin equals Celsius plus 273 to get our value in Kelvin. So we're going to plug in 227 and add it to 273 to get that our initial temperature is equal to 500 Kelvin. We don't know what our new pressure, or P2, is, as that is what we are solving for. And then we also need to find T2 in Kelvin, because we are told it in Celsius. So we're going to do 127 plus 273 to give us that the new temperature is 400 Kelvin. Now that we have done that, we could write our formula P1 over T1 equals P2 over T2, and we could plug into it. We get 10 atmospheres over 500 Kelvin is equal to P2 over 400 Kelvin. We could do the math on the left side, which is 10 divided by 500, to get 0.02, which equals P2 over 400. Our last step is to put 0.02 over 1 and cross multiply. 0.02 times 400 is 8, and 1 times P2 is just P2. So we get that P2 equals 8, or our new pressure is equal to 8 atmospheres, and that will be our final answer. Now that we've gone through some examples together, here are 4 practice questions to help you test your understanding of Gay-Lussac's law. Question 1 asks what variables it discusses. Question 2 asked about a pressure versus temperature graph. Question 3 asked what will happen to the pressure if the temperature is halved. And question 4 is a math question. At this time, I encourage you to pause the video, and the answers to these questions will be provided for you on the next slide. The solutions are as follows. Gay-Lussac's law discusses the relationship between pressure and temperature, and the graph of pressure versus temperature is an upward sloping straight or linear line, as seen on the right. If the temperature of the gas is halved, the pressure will be halved as well, and the answer to the math question is that the pressure is 2 atmospheres. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.